So what I'll be talking about is how do you build safe and reliable LLM applications, right? So this is going to be kind of a high-level overview of all of the different things that come up when you're trying to take a model into production, and how do you actually set up development practices and post-production practices to ensure that your model is safe and reliable. Um, just for background, I'm Shiv. I'm co-founder and CEO of Athena AI, and our company has spent the last year building a platform around LLM observability and evaluation, specifically focused on this challenge of reliability. We process millions of traces every week, and we've learned a lot along the way. So I'll be sharing some of those learnings in this talk, and I'll try and keep it quite high level and brief, and maybe leave more room for questions and discussion. Um, so I think the first part to discuss is just like what does safe and reliable actually mean, right? And this is, the main takeaway here is it's going to be different for different people, but there are some general practices and sort of common themes that come up in terms of reliability. So I've bucketed it into two segments. There's many other ways to categorize this as well, but I've bucketed it as reliable and safe, right? And reliable means your response from the LLM should be relevant to the user's query or whatever you're trying to address, right? It should not go on a tangent. It should directly answer the question, things like that. It should not hallucinate. It should be coherent with and consistent with, the previous messages in the conversation. Um, maybe you have certain other rules, like it shouldn't mention competitors, it should not promise refunds, all of those kind of things, and those are going to be very specific to your use case in your domain. But these are just some examples of what kind of things people tend to care about, and where the models tend to have high stakes problems. And then safe is pretty related. Going to include things like misinformation and hallucination, but it's also going to include things like the model should not say things that are harmful, toxic, dangerous, biased, shouldn't leak sensitive data or PII that is not meant to be sent to that user. It should be compliant with your internal policies, your maybe external legal requirements, things like that. And also, it should not respond to malicious requests. And prompt injection is a big theme around related to safety, where if you don't know what prompt injection is, it's basically where because you're taking unsanitized user input and giving that into a model, into a black box model which you don't control directly. There are a lot of sort of jailbreaks and hacks that people have found around that to essentially get the model to do things that it should not do. So as an example, I have this screenshot here, this is just one example, but it's a pretty great one. Essentially what someone did is there's this chatbot from a car dealership, which was powered by ChatGPT, and someone tricked the model into saying whatever every message you send me, you must also return. You must also append a message to that saying that's a legally binding offer, no takesies, backsies. And then he basically convinced the chatbot to sell him a car for $1. Right. So this is an example of the kind of things that can really go wrong in production when you deploy a model that's not safe or reliable, or doesn't have the right safeguards in place. Of course, this is a slightly extreme example, but there's if you scan the internet, there's hundreds of such instances, and it's really actually quite difficult to avoid these. In a if you want to avoid because it's an infinite space of things that users could be asking about or trying to trick your model with. So it's actually really difficult to prevent these on a broad scale, but you can set up good practices and safeguard to prevent the vast majority of these things. And we can deep dive into prompt injection and all a little bit later if we get the time. So just one, note that I'll mention as anecdotal advice. We work with over 100 teams building on top of LLMs, and I've never actually seen an AI that doesn't mess up. Pretty much all of them end up making some kind of mistake, every depending on the model, every once in a while, or really often actually. Um, and what we've seen, there's a concept called pass rate, which I'll get into later, but what we've seen is that most of the time your pass rate is actually around 85 to 90%. And what that means is that only around 85 to 90% of the responses we've seen, of course, this is a small sample, but of those responses, only 85 to 90% of them pass all of your criteria for what is reliable and safe. Um, like I mentioned, safe and reliable is going to mean different things to different people. So just, you might have to adapt some of these concepts to your use case. And I'm happy to chat and answer questions and kind of discuss that at depth if we get the time. Okay, so let's see. So how do we actually, build towards this safe and reliable a world where our AI that's deployed in production is actually um, going to be reliable and not going to mess up in the ways that you don't want it to. And there's three parts to this. There's the development side, the CI/CD side, and then there's the production side, right? And essentially, I'm going to talk through what are the different, like, kind of very practical things that you can do in development to prevent this. What are the practical things you can do in CI/CD, and then how can you set up safeguards and practices in production so that even when bad things do happen, you have ways to mitigate or manage those. So let's start with development. That's typically where people's workflows start. So the main takeaway in development is going to be some kind of test-driven development. It's also called metrics-driven development in this world. Um, and I want to just mention one thing, which is, test-driven development in the software engineering world is not new. People have known this to be, a way of doing things, but it's not, maybe not the standard practice. It's a practice that some teams follow religiously. With LLMs, the difference here um, is that there's really no other way to do it. If you want to be, really thorough and make sure your model is good across a diverse, wide range of scenarios, you're going to have to implement some kind of test-driven development practice because there's really no other way to measure quality, right? And what most people start out with, and that's perfectly fine for starting out and prototyping and building MVPs and demos, is eyeballing the prompts, right? Or eyeballing the responses rather. So you try something out, see how it comes out, and then just human evaluation, human review, just look at it and see if it's good or not. It's perfectly fine for starting out, but it is not what you want to rely on as you go closer towards a production application. If you do, it's going to be a recipe for very slow iteration cycles, and your results are not going to improve systematically. They're just going to, sort of fluctuate around some kind of mean. Um, and okay, test-driven development, the idea behind that is if you can measure the success, if you can measure how good the responses are, you can also improve them systematically, right? So how do you actually do that? It's not as complicated as it sounds. It can be pretty simple. In fact, I'm pretty sure we can, set up basic test-driven development for most use cases in like under 30 minutes. And the two things that you really need to do here are you need to create a suite of tests or evaluations, and I'll dive into those in just a minute. And you need to curate data sets, and those data sets should ideally be different ranges. So like maybe 10 examples, 100 examples, 1,000 examples. The reason you want to have that is if you're going to be running 1,000 evaluations every single time, that's going to probably take some time. Might be expensive depending on how you do it, and probably not the fastest way to develop. So you can have like these kind of different data sets for different stages of testing and things like that. Some quick tips for how can you actually set up these kind of evaluations. One, there's a lot of evaluation frameworks out there. We've built one of our own called, you can install it with pip install Athena if you're using Python. And what these will give you is really a framework for systemizing and standardizing evaluation across different types of tasks, different types of use cases, different types of measurements. If you decide to build it yourself, make sure that you have some kind of standardization layer in there so that you can run the same thing in development and CI/CD in production, and you can actually kind of compare these things against each other. LLM as a judge is this concept where you can actually use an LLM to do the evaluation. It's a little bit meta if you haven't heard of this, and it's definitely there are downsides with this, but the huge benefit of this is that it's really easy to set up. You're just giving an LLM a prompt, asking it to evaluate according to some very specific criteria. And it's very flexible. So you can use the same concept and you can write evaluations in a matter of minutes, and they're going to be pretty good if you do it the right way. They will not be perfect. It is an LLM, so there will be some margin of error on how good those are. But the key thing to do here is to think of it as a relative metric. So if you're running it on 1,000 rows and you change something in your model and you run it twice, the difference in your evaluation score is should not be very large. So LLMs as a judge are a really effective way of doing this. If you want an additional layer of abstraction, I would recommend starting with preset evaluations. We have a library in Athena. We have over 50 preset evals, and we've also integrated with open source libraries like Ragas, which are really good at this. And what you get there is really these canned, out of the box, off the shelf evaluations that work really well for common use cases. So RAG is a really, most people end up having some kind of RAG architecture. And with that, preset evals can be really helpful way of just getting started. And then when you find that you're hitting the limits with the preset eval, then you want to create custom evals. Again, if you use a good evaluation framework, you can extend that to create your own custom evals, or they might even have wrappers around it to like we do. So you can actually create custom evals pretty easily. Um, so just as an example of what kind of things you want to evaluate and measure, these are some common evaluations that we run for RAG pipelines. So you'll see that I've categorized it into two sections: retrieval quality and response quality. And the really important thing here is you do want to measure retrieval quality separately from response quality. The reason for that is that a lot of the time a lot of people end up over optimizing, over spending too much time trying to improve their prompts, whereas actually the problem is in their retrieval system. So if your retrievals are bad, your response is also going to be bad, right? It's very hard to have a good response if you retrieve the wrong information. So the ones on the left are actually just different ways to measure retrieval quality. We have some documentation around this that you can read and understand, and these you can use our metrics, or you can use different ones if that floats your boat, but definitely measure the retrievals separately from the responses. So these ones are all just different ways to measure how good that retrieval is. On the response side, things like faithfulness or groundedness are pretty useful. What they measure is they're very good proxies for hallucinations. So what they measure are things like when the response says something that is not backed up by your retrieved data, then that's often, if you have a closed RAG system, then that's often a very good indicator, a proxy for hallucinations. Things like conversation coherence are, that's a metric that we've designed, which essentially checks if every message in a chat, so this is for chat applications, if every message is coherent with respect to the previous messages. And that tends to be pretty important for conversational use cases, because we often find that, especially with smaller models, the 10th message is going to be a lot worse, or the 10th response from the AI is going to be a lot worse. It's going to forget something than the very first response from the AI. Um, and just to show you kind of what that system looks like, so if you use Athena, then we have an SDK where you can run those in a Python notebook, or you can, that also shows up in our platform. And essentially it's super simple, just like red and green for what's good and what's bad. And this kind of lets you you can run thousands of evaluations in a matter of minutes and quickly scan and see where things are good or not good. So as an example, if you look at the bottom part of the screen, I can see that my Ragas faithfulness metric here is 0.75 average, and my context sufficiency is 0.94 average. So what does that tell me? That tells me that, okay, my retrieval system is not bad, because context sufficiency um, is essentially measuring if the context contains enough information to answer the query. And so if you have a lot of green in there, then you know that that's doing pretty well. But faithfulness, which is measuring if your response is actually staying true to the retrieved data. That if that's low, then that means your model is straying and probably hallucinating and making up things that are, maybe not were not provided in the data that you retrieved. Um, so setting up some kind of system that lets you do this rapidly is going to be really important for testing, for reliability and safety as well, right? Similarly, on the development side, one really common LLM developer workflow that you'll eventually end up having is you want to compare different sets of data, which might mean you're trying to compare. So you start out with a common list of queries, and maybe you change your prompt, or you change your model, or you change your retrieval system, and then you run the pipeline again, and then you measure and you see if things improved or became worse, right? So this is going to be like kind of the gold standard for how do you improve systematically, change one variable at a time, run the pipeline again with the same queries, the same data set, and then see what improves or doesn't improve. Again, that's something you can do on our platform. Um, and then if we jump into the CI/CD side, by the way, I know I'm rushing through some things. I'm happy to deep dive if we get time, but I want to make sure I just cover some of the production stuff as well. So um, on the CI/CD side, it's honestly quite similar. It's not, there's nothing super complex going on. You run the same kind of evaluation, make sure that you have a really good data set, and make sure you have some threshold values for what is good and bad, what is pass and fail. And then if your score is below the threshold, you fail. If your score is above the threshold, you pass. This is super easy to set up in, if you use something like GitHub Actions, and you already have your evaluation framework configured and all of that, you can set this up in like 15-20 minutes. And what this ensures is that bad changes don't get into production. So you change your model, you change your prompt. Sometimes you don't even change the model, but the model changes under the hood because you're using the API. And this will help you catch those kind of things. So it's going to help you make sure that bad changes don't get into production, and that's going to improve your reliability a lot. So these are some practices we see from the best teams that we've worked with. Um, and a couple of quick tips here are you want to make sure data set, especially the CI/CD data set, is large and diverse, should have representative examples of real user queries. If it's production examples, then that's best. And ideally, you should also test for malicious queries, prompt injections, things like that. Really examples which are not going to be common from real users, but they will show up, and people will push your application to the limit. And think of this as like you should have some data set which is really almost like a red teaming data set, where like you're specifically including examples where you're trying to trick the model into messing up, right? And if you have something like this and you can measure how often that's happening, and you can make that number go up, then or sorry, make that number go down, then you have a pretty robust system where that that your model is resilient to all of these different all of these different types of attack vectors. Um, and so, okay, so now we've gone through the development cycle and what you can do in CI/CD to make sure bad changes don't get into production. But in production, you're never going to have 100%, as we know. So what can you do, to safeguard in production itself? There's going to be three things that I'll just briefly touch upon here. One is setting up a guardrailing system. Two is running the evaluations in production. So the same kind of things that we discussed earlier, running those in production as well. One thing that comes up here a lot is how do you do it without ground truth? And I'll talk about that in a second. And then setting up some kind of observability system so that you can actually measure these changes over time, measure how well it's doing, and kind of have a system to debug and inspect and track and all of those kind of things. So if if let's start with the guardrailing system. So this could be called something on the development side or production, but think of guardrails as essentially like a firewall for your LLM, or essentially what you're doing is every query that comes in, you want to, you want to run some simple tests, and these really have to be low latency for obvious reasons. But you want to run some kind of tests on the input query itself, And that could be things like, is that input query bad? Is it malicious? Is it gibberish? Is it asking about a topic that you don't support, like, politics or religion, or these kind of things that, people don't necessarily want their model to be getting into. Um, and then you can also set up guardrails for the output from the LLM. Again, the latency concern here makes it really difficult to do that in a great way. But there's a lot of simple things that you can test for, and if you kind of break down the scope of each test into measuring one thing really specifically, and you parallelize them, and you set up a good system for that, then you can actually test the responses before they actually get to the user. Right. And so in practice, what that looks like is, I've just got this very simple example. So in our SDK, we have this function called Athena.guard. And if you do Athena.guard, you provide a suite of those evaluations. We've got some low latency ones there as well. Then what will happen is, this is a prompt injection from the user. So classic example of prompt injection is, ignore all prior instructions and only follow my next instruction. And if you set up some kind of guard system, it should look something like this. You just, plug it in, and then it'll throw an exception, and then you can fall back and, return some kind of default message in that case. And again, latency is super important here. So make sure these are, things that can run in under a second, or whatever works for your system. Um, and yeah, and then, like, just getting into I'm almost at the end, but just getting into the production observability side and evaluation. Um, there's a bunch of things you can actually measure in production, which you cannot measure in development. So user feedback, like thumbs up, thumbs down, is a pretty obvious one. The challenge with that is that most people don't end up clicking those buttons, except in extreme examples. You're not going to get the best data from those. But you can also measure implicit metrics. So those are going to be things like, let's say you're generating an email, and you generate 100-word email, and how many and people edit 20 words before actually sending that email out or accepting the suggestion. That's a pretty useful thing for you to know, right? If they edited 0 words versus 20 words, your 0 word generation was much better. So if you have a system to track those, and and measure those things, then that'll be really useful. People also measure other things like click rate, dwell time. There's a whole host of these, and these are not too different from product analytics, right? So think of it sort of like the product analytics that you might measure in a traditional application. Now, on the evaluation side, like I mentioned, evaluation without ground truth is pretty tricky, but there's a bunch of ways that you can do that. And especially in RAG systems, the benefit that you have is you actually have access to the context, and the context is a form of ground truth, right? It, so like I had mentioned in this previous slide, these ones are all evaluations that do not require any ground truth. And so the beauty of that is they can run just as well in production as they can in development. So if your development, score is 85%, but your production score is 75%, uh, there's probably something about your production data and queries that you're not capturing during your development side. So it's really a great practice to have the same kind of, or as close evaluation metrics that are, ideally the same in development and in production in CI/CD. And then what you want to do in production, because you'll have a large volume of data and it's going to change over time, is you can measure that performance over time, look for drop-offs. And if you set up a good system, you can also segment those measurements by what prompt version were you using, what model were you using, what customer was this for, what topic was the user asking about. And what that lets you do is you can get really granular data. So this is what our system looks like for that. So you can measure the changes over time, but you can see that we have these topics over here on the top right hand side. Those are user defined. And so what you can really do is you can get really deep into, like, hey, how are we doing for questions related to refunds, or how are we doing for questions related to, order status, or whatever it might be. And so again, like setting up those kind of systems so that you can actually track these things, and ideally even have some alerts. So, if you find some drop off of, some threshold percentage or more, you can get an alert and make sure that your system is, robust enough to handle that. So that's the end of the, the canned presentation, but I'm happy to just discuss more and like answer any questions if there are any, and if we have time.
Yeah, so it does look like there is one question. And for context, it was around slide 910. Harsh asks, can you give an example of a preset eval?
Yeah, so these are some examples of preset evals. If you look at these, the ones that I touched upon, maybe you asked this question before that, but essentially, like we've got a library of 50 of them. I can just quickly pull that up if you want. Just to show you. But the different types of things that we have as preset evals are going to be, so there's all of these ones for RAG systems, the RAGAS ones, measuring things like coherence, conciseness, maliciousness, harmfulness, those kind of things are useful. We have these safety related evaluations. So, PII, like detecting if there's PII in the output or in the input, actually. OpenAI has an endpoint called content moderation, which you can actually turn into an eval to measure if there's, different types of bad content in your response. Um, there are preset evals for summarization, for data extraction, or you can even just have very simple functions for like, does it contain a competitor's name? Does the response mention any of these topics or keywords or things like that? So there's really a whole host. We have 50, there's dozens of other libraries as well. And these are the goal of these is really like off the shelf, easy way to set it up, start out, and just get started with measuring these things.
So you do have a second question, which is how are you setting up guardrails on user input? Like, do you have a text classifier?
Yeah, so guardrails, again, like the way that we think about it, if we talk about this one, for example, the way that we think about it is Athena.guard is sort of the execution function, which will run these evaluations, and it does a few things under the hood to, parallelize them and speed them up. But the each evaluation that you pass into the suite is going to be an independent function, which is essentially all it's doing is this is more of an abstraction. In your case, it could be anything, but all that is doing is it's taking some kind of text input and returning a Boolean pass or fail output, or maybe a number. So yes, a text, like what is the specific of that evaluation depends on what you're trying to do. So as an example, this prompt injection evaluation that we have, it's based on an open source Hugging Face model, which is a fine-tuned DBERTA model. So it's a pretty small, low latency language model um, which can check for prompt injections. Sometimes it could be as simple as a function that just checks for restricted keywords. Sometimes it could be a text classification model. There's really a whole like it could be anything. Just think of it as a function that maps from an input text to a Boolean pass or fail. Um,
And it does look like we have one final question, which is how do we set custom evals? And I think it's and custom functions.
Yeah, so I mean, if you use like I can tell you how it'll work in our system. Again, just like think of an eval, like the term is a little bit overloaded, but just think of an eval as literally just a function which takes some input, which could be either a single input like a piece of text, or it could be a tuple of inputs, like for example, a query and a response, or a context and a response, right? And then you want to map that into a ideally a Boolean pass or fail. So the way that our custom evals work, if I was to just pull that up over here, we have a few different ways of doing that. We've got this, grading criteria, which is just essentially just like if X then fail, otherwise pass. So we just use a language model for that. Same custom prompt is the same idea, but you can put a completely custom prompt in there. We have this API call evaluator, which is essentially you define a function on your API server. We'll just hit that function and expect a Boolean response over there. The great thing, by the way, one thing I didn't mention, a really great thing with using LLMs for this stuff is that you actually get an explanation. You can get an explanation for the pass or fail along with the actual Boolean result. And the great thing about that is when you're trying to, inspect all of these in production, you're trying to see, so the way that you're trying to see why it passed or failed, you can actually just see you can see the explanation as a result over here as well. So just like, you come in here, you see this, I can see all of these evaluations have failed, and these are actual production evaluations that have failed. And I can see that, there's an explanation from this model on why it failed. Of course, what model you use is going to be a big factor in how good these evaluations are. We found there's a significant performance benefit from using GPT-4 or, one of the flagship models. But the thing that you can do to really to minimize your costs is, one, you can do some sampling, and the second thing is break up your evaluation into really small kind of discrete tasks. So it's better to have an evaluation which is just checking for one specific thing. That's going to improve the reliability of the evaluation itself. So how good is that evaluation? And it's also going to make it possible to run that on cheaper, smaller models. So we've been able to run these, really simple, LLM-based evaluations, LLM as a judge style evaluations, even with models like Llama 2, that is, and GPT 3.5, and with really high degrees of accuracy, as long as the task that they're trying to solve is really simple. The idea behind that is, the more complicated the task, the more likely it is that your LLM is not going to be able to do it, or a smaller, cheap model is not going to be able to do it. So one trick, for example, that you can do there is, instead of evaluating an entire large response as a whole, break it up into different, like evaluate each sentence separately, right? And you can ask the LLM to do that as well. So you can, like for groundedness, what we do is we check each sentence individually, and then the score that comes out on the other end is how many sentences were grounded versus how many sentences were not grounded. And so that gives you an indication of your model's groundedness. But it's also something that small models are actually remarkably capable of, because evaluating one sentence at a time is not that difficult of a task, right? But evaluating a giant response with 1,000 words is it's going to have a much higher margin of error with the models.